Let's discuss the top 5 agentic frameworks in 5 minutes. As the artificial intelligence market is flooded with AI startups, a common pattern is emerging. Many solutions presented as deeply innovative are in reality sophisticated interfaces that primarily manage API calls to foundational large language models. By themselves, LLMs are like brilliant brains trapped in a jar. They lack the ability to act, memory, and direct interaction with the world. This is a fundamental limitation that prevents the creation of practical applications beyond simple conversation. At the core of every advanced AI application lies the need to give the LLM access to data and functions beyond itself. From this need, Agentic AI was born, transforming LLMs from passive tool into proactive autonomous agents that plan, use tools, and make decisions to achieve complex goals. To harness this power and impose order, Agentic AI frameworks emerged. These act as the architects, providing the structure, tools, and orchestration mechanisms to build and manage intelligent agents. However, the rapid evolution of the field means that the systematic understanding of their differences in design and capabilities remains an open challenge. LangGraph. LangChain has emerged as the classic tool for this purpose, simplifying the creation of linear predefined workflows known as chains. When a user submits a query such as, "What can I make with chicken, lemon, and peach?" the system activates a linear and deterministic response process, which begins with recipe retrieval via semantic search on an internal vector database like FIS to identify the most relevant recipe. This approach is exceptionally reliable for simple question answering tasks, as it executes a predefined linear sequence, search, format, and answer. LangGraph, built upon the LangChain framework, introduces a sophisticated graph-based model designed to orchestrate complex stateful workflows. LangGraph's architecture is founded on the state graph, which transforms linear chains into a dynamic system for workflow management and decision-making. At its core lies a central state, which serves as the agent's shared involving memory, allowing it to remember and accumulate information at each step. The operation of a LangGraph agentic system begins with a user-defined goal, which activates a dynamic graph. The initial planner node, leveraging an LLM, reconstructs the goal and updates the standard state. The flow then transitions to the worker agent, which invokes the necessary tools, such as performing an inventory check. The outcome of this action is evaluated by the reflector node, the critical decision-making hub. Based on the current state, such as missing ingredient, the reflector can loop the flow back to the planner for a complete replan, instruct the worker agent to retry, or if the execution is successful, proceed to the final answer node. The final output of the agentic system is dynamic and adapts according to the conditions identified during the plan's execution. No agentic system is complete without robust observability, and to this end, the LangSmith platform complements the LangGraph ecosystem by serving as an integrated control center for the entire application lifecycle. CrewAI. CrewAI is an advanced multi-agent framework built on LangChain, designed to orchestrate the collaboration of specialized agents, enabling them to solve complex tasks while leveraging their collective intelligence. The architecture of CrewAI is organized around the fundamental building blocks of agents and tasks. Agents are autonomous units that undertake specialized roles, each defined by its goal, backstory, and delegation capabilities. The core philosophy of CrewAI defines agent collaboration not as a family bound by emotional ties like in Fast and Furious, not as a squad of disparate specialists like the Suicide Squad, but as a crew, like in Pirates of the Caribbean. CrewAI operates at a higher level of abstraction, focusing on the collaboration of a specialized team of autonomous agents to achieve a complex goal. The entire operation is governed by a visual process, a workflow where the output of one task becomes the contextual input for the next, ensuring a seamless and logical progression. CrewAI strikes an ideal balance between simplicity and complexity, offering developers superior flexibility over no-code tools, making it the premier choice for building robust, production-grade AI systems. Pydantic AI. Pydantic AI represents a natural evolution of the Pydantic ecosystem, aiming to become for generative AI development what Fast API became for web development. The framework's core philosophy is to leverage type safety and data validation through a schema-first design, transforming LLMs from simple conversationalists into structured, predictable agents. To address exceptionally complex multi-step problems, the framework incorporates Pydantic Graph, an advanced library that implements an asynchronous finite state machine architecture. Consequently, Pydantic AI distinguishes itself through its lightweight and transparent composition. Rather than being a heavy monolithic framework, it offers a minimal yet powerful solution that prioritizes developer understanding and control. MetaGPT. Developed by Deep Wisdom, MetaGPT is an advanced metaprogramming and multi-agent collaboration framework based on LLMs designed to automate the software development lifecycle. The heart of its architecture is clear role specialization and the implementation of standard operating procedures (SOPs). These strict workflows guarantee tasks are executed consistently, achieving effective coordination. Each agent has a well-defined role with a specific profile, goals, and skills. The typical flow begins with a product manager creating a product requirements document (PRD). The architect translates this into a technical design, the engineer writes the code, and the Q&A engineer tests it. This structured sequential flow, aligned with the industry practices, allows complex projects to be broken down into manageable subtasks, minimizing the risk of information loss. Consequently, MetaGPT is a transformative tool for rapid prototyping, answering the question, can we build this? And creating minimum viable products, MVPs, answering, should we build this? Microsoft Agent Framework. AutoGen, a powerful open-source framework from Microsoft, was designed to simplify the development of AI systems based on multiple collaborating agents. However, its broader adoption in production environments faced hurdles due to a lack of standardized APIs and enterprise-ready capabilities. Semantic Kernel is a lightweight open-source SDK designed as the fundamental core for enterprise-grade AI applications. Its architecture is organized around the kernel, which coordinates plugins, planners, and memory, supporting RAG. Recognizing the need for a unified tool, Microsoft created the Microsoft Agent Framework, MAF. This framework unifies the enterprise maturity of Semantic Kernel with experimental orchestration patterns of AutoGen, now representing Microsoft's main investment point for multi-agent systems. At its core, an agent acts as the orchestrator, coordinating the thread, conversation history, memory, data context, and tools. Middleware plays a critical role, acting as a control bridge for both LLM communications and tool calls. Microsoft Agent Framework offers the advanced orchestration pattern supporting two approaches: agent orchestration for dynamic creative interaction and workflow orchestration for deterministic graph-based business processes. Designed for immediate production readiness, MAF integrates enterprise-class features. As agents become increasingly autonomous, capable of handling complex tasks from start to finish, our own role changes. It shifts from executing the work to designing, architecting, and supervising these powerful systems. The question, therefore, remains, what is the new role of human expertise in this new, exciting world being built before our eyes?
Tech in a flash, that's how we ride. Stay tuned, stay smart, it's 5 Tech 5.